Good morning. This is Jaladi Anindya Kiran, working in Vignan Institute of Technology and Science as Assistant Professor of Physics. Today, I would like to give you the introduction part of Applied Physics, which is a subject in first BTech. And let us see what are the course objectives. So, the Applied Physics is going to give us a insight of scientific inquiry and problem solving techniques that are present, and students will be able to demonstrate and understand quantum mechanics, fiber optics, lasers, semiconductors, physics, and electromagnetic theory, and so on. So this particular subject is having the course outcomes as follows, which are shown here, and which is going to give us an insight about semiconductor physics, optoelectronics, and communication, solar cells, photoelectric effect, and so on. And further, this particular chapter, applied physics consists of 5 units. The first unit is nothing but quantum mechanics. Quantum mechanics is going to deal with the introduction about the quantum physics, where how this quantum theory came into existence after the classical mechanics is being explained in detail. Black body radiation and understanding the black body radiation and the laws which are explaining the black body radiation, and further the actual understanding about the black body radiation in terms of the particle nature of the light is being demonstrated or explained in this particular unit. Photoelectric effect, Compton effect proves the particle nature of light. De Broglie's hypothesis gives us an understanding about how particles are behaving like waves, and how Davison and Germer's experiment demonstrates or gives us an understanding about how the particle is behaving as a wave. And further, the knowledge about this particular wave pattern exhibited by the particles are explained in Heisenberg's uncertainty principle and Born's interpretation of the wave function, Schrodinger's time-independent wave equation, and particle in a potential box. Now let us see from where this particular theory or the quantum theory is being proposed or enhanced from an earlier stage. Christian Huygens gave us an understanding about light as light consisting of waves. Light is consisting of waves according to Huygens, but the light is consisting of some corpuscles, which is nothing but a particle according to Isaac Newton way back in 16th century itself. But in 1860, a person known as Kirchhoff explained the black body radiation and in detail, and according to him, the light emitted by a black body is called black body radiation, and at room temperature black bodies emit IR light, but as the temperature is increased past few hundred degrees centigrade, the light is going to start emitting different wavelengths, which include red, orange, yellow, white, and so on. And beyond that limit, if you further increase the temperature, you come up with blue, and later, if you still increase, you will also be able to get the ultraviolet rays. Next, the photoelectric effect gives us an insight about how a light is being giving us the particle behavior, and it is being explained first observed by Hertz, and it is being explained by Einstein, for which Einstein obtained the Nobel Prize. As you can see here, the diagram, which is the circuitry diagram about the photoelectric effect. Another effect which is also explaining the particle nature of light is nothing but Compton effect, which was explained by Compton, and it is giving us an insight how when light is interacted with the matter, and this light is going to have a varied wavelength values after the interaction with the matter. Now, and the particle nature generally exhibited by the particles are also exhibiting the wave nature, which was hypothesized by de Broglie, and experimentally it was verified by Davison and Germer in 1927. And this particular experiment gives us an insight about how particles could be acting as waves. All these experiments proves us the particle nature of light as well as the wave nature of particles. All these things are giving us the basis for the quantum mechanics.